Hi everyone, welcome to Fabric Webinar Episode 2. Today we'll be deploying containers to Fargate. I'm Shashank, I'm your host today, and this is the Fabric Group channel. If you want to get in touch with Fabric Group, the link is on the page below. I will share this link with you. It is already in the description of the video. And on this page, you will find the relevant links here. The Fabric Group link is also here. Please get in touch in case you want to have a catch up or in case you want to just talk. So today's session is a build up on the previous session which we did, the first episode where we played around with Docker. In this session, we will deploy Docker to Fargate, which is a container orchestration service from AWS. Awesome. So let me give you uh, a brief about the structure of the session and also what are the expectations and who is this for. So if you have attended episode 1, you will know that this is a kind of free flow session. We will play around with the tools. We will do a kind of deep dive into things, and also feel free to push or like to ask any questions. I know I didn't do a very good job in the first episode, but today I will try to take as many questions as possible, and I will keep an eye on the comment section here. Hello, Chris. So. So let's start with this. So there are two links in the description. One is for the GitHub repo, where we are trying to document all the episodes. So you see here, we already have episode 001, all the notes about it, and I created this episode 2 agenda here. There is another link which is a direct link to this HackMD website where you can see the same agenda and you can also go and edit it. I will appreciate if you can go ahead and add more stuff here. You can add comments, you can add feedback, you might even add a questions section here if you want me to pick up some questions at the end of the session, or feel free to edit anything here, like maybe add the commands which I'm typing. This is for you. Once the session is done, I will take this and I will commit it in the GitHub repo. So that is some housekeeping. What we will cover today is, let me quickly go through this. Yeah, before that, so who is this session for, and how much detail we will go in? So we will deploy containers today to Fargate, and some assumption is that you already understand what containers are, and you have played around with them a bit. Some working knowledge of AWS would be helpful because we will touch upon networking, we will touch upon some IAM permissions. So that will be very handy. Beyond that, I think I will try to explain everything as we go, and things should be fine. Just feel free to post your questions, and I will keep taking them. And we might slow down in case someone feels it's not working out. So feel free to throw out those questions in the comments. Uh, let's get started. So actually, before that, one more thing. So we did the last episode, and it is already on YouTube, but it is a bit out of sync. The audio is out of sync from the video, so we are trying to fix that. Um, just keep an eye. We might upload a fixed video soon, and hopefully uh, today. I hope that the stream works out fine. If it doesn't, I promise we'll be back in case things break. So awesome. So let's talk about Fargate, and let's dive into the session. There are quite a few things to cover here. Last time the session went on for like 1.5 hours. Today I will try to finish it within 1 hour or maybe before that. So I am very conscious about how much depth we will cover here. But I will try to give you a good enough overview of Fargate to start with. And if you are already working on it, maybe it will be some fun to pick up new things. A small twist here is, so in the documentation, in the description of the video, we mentioned we will do all this using AWS CLI, but we will not do that. it's painful to do all this through AWS CLI. I realized it while preparing for the session. So we will do this through PullUMe. I will quickly touch upon that also, what PullUMe is. And I promise we won't go in depth of that, and I won't let PullUMe hijack the session. I will keep it very simple, and it will mostly be focused around Fargate. So PullUMe is just a tool which we are using. Cool. So what is AWS Fargate? So let me share few things here with you. So AWS Fargate is a service from AWS. It is it is one of the many services out there which help you deploy containers, to orchestrate containers on multiple nodes. You might be aware of Kubernetes or services from Azure or Mesos in older days. And in Docker, you might have heard about Docker Swarm, Docker Compose if you do it locally, though it's not like orchestration service. So this is one of the tools which fit in the same ecosystem. And what it let you do is you give it a bunch of containers and you give it a configuration around it. You tell it how you want these containers to be deployed. And beyond that, you do not have to manage the nodes yourself. So AWS manage those nodes for you, and you just your containers get deployed or like spread across the available nodes. We will go in the depth of this, like how you do this, and we will also cover like the concept of node and like what goes in there in the task. So let me quickly share a few images here with you. So yeah, so what happens here in Fargate, right? And what happens generally when you deploy containers on cloud? So your container is a kind of wrapper around the process or the app which you want to deploy. And when you deploy it you eventually deploy it on a running virtual machine or something which has like which is either a bare metal or like either a virtual machine on the cloud, right? So your containers finally get deployed on top of these nodes, and there is no limit, like no hard limit on how many containers you can deploy on a node. It depends on how much memory and CPU you are consuming. So what you want to do is you want to effectively use these nodes, right? And you want to distribute the containers between multiple nodes. So let's say you have 50 containers and you have like 10 nodes. You might want to distribute them depending on the payload, right? Depending on the workload. So what happens in the scenario here is you have on Fargate. So you have the concept of node, which has underlying operating system, which most probably is like AWS Linux or some other operating system. It's completely hidden from you as a user. On top of that, you might have a container runtime running like container D or Docker. And what AWS provides on top of it is a container agent. They call it the Fargate container agent. But I think it's common for what they use in ECS also. And this agent takes care of the task which you give it, the task which you define in AWS. This agent takes care of converting the task configuration into runtime containers and distributing it across multiple nodes. So there are two different services from AWS, and both of them fall under ECS, Elastic Container Service. One is Fargate, and one is the EC2 ECS deployment type. Uh, the difference between these two is in the EC2 ECS container deployment, you manage the nodes yourself. So you bring up the EC2 instances, then you install the container runtime, the container agent on top of it, which essentially is most of the time bundled, given as a bundle by the AWS AMI image. So you do this, and then you tell AWS that these are the nodes which you want to use for this particular ECS cluster, and then you give it the containers, and the containers are deployed on top of those nodes. But in this case, you are responsible for managing the nodes for the patches, the security updates, and like everything underlying those nodes, right? And it becomes really complicated. So in some scenarios, you might want to own it, and that's what you do even when you are deploying on something like Kubernetes, you do manage your nodes and you do manage the full cluster, right? But in some cases, you might want to deploy a few containers, and you don't want to spend time on managing these nodes. So what you do in this case is you can opt for Fargate, which manage the nodes for you, right? This is the service offering from AWS. So let's see. So what we will deploy today in our session today. So this is how our deployment will look like. Finally, uh, Voluminicity is saying hello, 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 Lyra Digital. Thanks for joining. So this is how our guys, feel free to keep posting questions as you go. I will keep taking breaks in the middle. Before I move to the next session, I will leave out some time to answer the questions. So please feel free to post them here. So this is what we will deploy today. This is how our deployment will look like. We will have a VPC, a group of subnets, public and private, and we will first deploy a single container into the public subnet, and then finally we will deploy it into the private subnet and hide it behind an NLB. And we will see different moving parts here. We will see the concept of service, the concept of task, and few roles, and we will also use an ECR for all this. So let's jump onto this. I will quickly share my screen with you guys. Awesome. So I just realized my screen was not shared, but it's okay. I haven't covered much yet. So yeah, so here we are. So this is what I was talking about, the concept of node and the concept of container runtime and container agent on top of it, right? So in case of Fargate, you do not have to manage the node yourself. AWS manages it for you. But if you're deploying on EC2 and you're using the same ECS layer on top of EC2, then you have to manage your nodes, and the containers still get deployed using by the container agent here. So in our case today, we will not manage any nodes. We will do it on Fargate, and you will see that we won't touch EC2 or anything. It's like the service offering is called like serverless for containers. And what we will deploy today is this. We will have a VPC, public subnet, private subnet, and we will have containers deployed in the private subnet, load balancer in the public. We will start with a simple container in the public subnet, then we will eventually move it to the private subnet. And there is the repo, or the ECR repo, and then there are multiple tasks, the IAM roles, which we'll talk about. And we'll touch upon the concept of service and tasks. So I will jump onto the actual code now. We will use Pulumi for this. I will give a quick introduction about Pulumi. Uh, any questions so far about the deployment or like about anything else? Cool. So Pulumi is one of the tools which let you write infrastructure as code. It's a very it's an awesome project. I would recommend go and check it out, play around with it, and maybe use it if the use case fit for you. So today we'll use Pulumi. We will not use AWS CLI. It is painful to use. Uh, in one of our previous engagements, we have used AWS CDK, and we have generated like more than 80,000, 90,000 lines of code using AWS CDK. And we had a project where we deployed multiple containers and lambdas, and we had like a whole bunch of CI/CD pipelines around it, all configured through AWS CDK in code. And from my experience, I can tell you it's extremely powerful to do this in code. A whole bunch of new patterns emerge, and you can share your code as libraries, right? But today we will do a very simple stuff. We will not go in depth of this. Maybe we will have a different session on this later. Um, so let's start with it. So what I've done is, as part of the session, because there are certain things which take time to deploy. Uh, so we have the network load balancer here, which we want, and the the network around it, the VPC network. So these are the two things which I have already deployed because the load balancers generally take a lot of time to come up. So I will not, I don't want to waste that time here in the session. I'll quickly show you what I have done so far. This is a single file which we'll use to deploy everything, and you do not have to understand like how this works. I think that the code written here is fairly simple and it will make sense. Just try to see what we are deploying, and that is good enough. So I have already created a VPC network here. We have two public and two private subnets. So there are two availability zones, and the code which I'm using here automatically create one public and one private subnet per availability zone. So we have like four here. And then I have just created one NAT gateway to save some cost. So let me quickly show you what we have here on AWS. Uh, so this is the load balancer, which is already created. And if you see, there is a listener, and it might not point to anything right now. Yeah. So there are no targets in the target group. So it's not attached to anything right now. And I'll quickly show you the VPC also. So the VPC here is this one, and if I go to subnets, I have two public and two private subnets here, the top four which you see. So this is the network which we will use, under which we will deploy, and the load balancer we will use in the later part of the session. So few questions here. Yeah, is node equal to isolated data center or isolated hardware? So it's not equal to isolated data center. What you can think of it is as an EC2 instance running somewhere within the AWS network. So you do have, or like if you put it in a VPC, in your own VPC, then it actually runs within your VPC, but it's completely hidden from you. So you do build a cluster around it, and the cluster can sit in whatever network you build, like the VPC network which I have built. The full cluster of nodes will sit in there, but I will not have access to the nodes. The nodes will be completely managed by AWS here. If that answered your question. Yes, so nodes are not primarily used for failover here. So nodes are the underlying machines on which the containers will run, and the node is not managed by the developer or like by the DevOps person here. It's managed by the AWS. But if you deploy it on the ECS EC2 version, then the nodes will have to be managed by you, and they are actually EC2 instances where you deploy this. And in fact, the Fargate runtime which we use, the container agent which we use, is very identical for both EC2 and the Fargate. So the underlying concepts are same. The only difference is that the nodes are not managed by you. Awesome. So I hope that answered the questions. So let's jump onto this. So what I will do now is I will first take a container which I have on my machine. Let me quickly show you the container. So let's say, so this is one of the containers I think which we played with in the last episode. It's a simple Golang app. And if I show you the Docker file here, it's a fairly simple Docker file, a very small size. It's built on top of distroless, and it has a single endpoint, actually two endpoints, one called goose, which just says hi, and a health check. So let me run this locally and let's see. So I will say goose, and let me say expose port 80. I think it runs on 8083. Cool. So this is the one which I built from this Docker image. And if I run this locally and I hit this, let me say 83 here, and you say it just says hi. There is one single endpoint, and there is again another endpoint which is like heartbeat, which is used for which just returns 200, which is used for health check. It's a very simple container. So what I will do now is I will create an ECR repo and I will push it to the ECR repo. So I can do this, I can push this to the Docker Hub and we can directly use Docker Hub, but I want to do everything on AWS in this and I want to try to keep it as close as possible as it will be in a final project which you do, or as close as possible as it will be in the AWS ecosystem. So let's do everything on AWS. So I will go ahead and create an ECR repo. So if you see here, we have some code written to create the ECR repo here. The repo is named Fabric Webinar Goose. And if I do PullUMe up, this will show me what changes are going to be applied now, uh, which should be the ECR repo. So first thing with VS Code, always save your files. So yeah, so it should show up now. And once this is done, we will have ECR repo, which will show up here. So let me say yes. So as you see, it is showing that we'll create the ECR repo, and once it goes through, it should be very quick. Awesome. So let's refresh this. Clusters, repositories. Yeah, so this is the one which we created. And if you see, we do not have any image here. So what I will do is I will push the image to this ECR repo. You have to do some steps to push it there. So let me quickly close this. So this is the step which will log me in to the ECR repo, and this will not work because I have to use the correct AWS profile. So, yep, this is fine. And let me do this. Awesome. So, let me push the container here now. Build is done. Tag. So we have to tag the image first. Let me tag it. So the tagging here is our container is named Fabric Webinar Goose. And this is fine, looks fine, done. And then we'll just push it. Yeah, so this will push the container image. And this container image is will be pulled by the Fargate runtime. And we will see how that happens. So let's refresh this. And you see the image is there. It's like 16 MB in size. Awesome. So nothing much here to explain. Let's move on to the next step. And I think there are some parts where the Fargate runtime need permission to talk to this ECR rep and pull the image, and we will see how that is done using the IAM roles. So let me move to the next step. Yeah. So let's talk about the concept of a cluster. So what happens in ECS, AWS ECS? There is a concept called cluster, which is just a logical boundary around your workloads, your container workloads. So if you see here, if there are two categories here, EKS and ECS cluster. Today we are covering ECS, so I will go under ECS. And if I create a cluster, it gave me a few options here. And the first one is the one which you are going to use for Fargate. And I won't create it. I will just go and show you what happens here. So you can give it a name. You can put it in a VPC. When you put it in a VPC, what happens is that the containers which you will deploy within this cluster uh, will be deployed within that VPC. And beyond this networking concept, there is not much to the cluster. So there is no limit that the containers from one cluster can't talk to another cluster. You can do all that. It is just a very simple logical boundary to kind of pre-configure a few things about your workloads, like how they will be distributed. It's just a very simple concept. So let's do this from Pulumi. So here what I'm doing is I'm creating a Fabric webinar cluster, and I am not creating any security groups around it right now. We will create security groups separately. And I'm saying that put it in the VPC which I created earlier. And when I say put it in the VPC, it actually doesn't create anything. The cluster is just some configuration which sits in AWS, which is actually consumed when you deploy your containers. So the VPC here would be referred to when I deploy the Fargate container. So right now it will just create a configuration and put it somewhere on AWS. So let's do this, save it, and do PullUMe up. So one more question here. Can't see what you are typing. That is very weird. Is uh, is the font size small? I can make it bigger to help, but I'm not sure if this is the video quality or if this is the font size. Can you please verify if you can see it now? Just let me know in case. Oh, okay. I see what you mean. So, okay. So I will keep typing on top. I will keep it on top. Uh, I'm not sure why it is cut off. It might be the screen here. Let me quickly see if I can fix it. Yes, I see what you mean now. Mm, just give me 1 second. Sorry about this. Uh, I hope it's better now. Okay, awesome. I think it should be fine now. Cool. So what we have done is I have created the cluster, and let's see if the cluster starts showing up here now. Yes. So this is the cluster which we created, and the Fargate task. Guys, can you see the full screen text now? I hope it is working. Just let me know in case it is not. Cool. So cluster is up. Let's move to the next step, which is um, creating the security groups. So I will create a security group here, one security group, which we will use for our task. And what the security group is doing is it's saying allow all the outbound traffic. So whatever goes out from the container, just let go everything. And we can restrict it. It only need to access the ECR repo, but the ECR repo is hosted over public internet in in AWS. There are ways to make it private, but I won't talk about it. So it has to go through the internet, the image pull process. So I'm saying all outbound is allowed. For inbound, I'm saying only allow traffic. Uh, okay, awesome. It looks fine now, I think. Okay. So yeah, so it is saying only allow traffic on port 80, which is the one which we will expose. Cool. So let me create the security groups. These should be created fast. And once the security groups are up, then we will move on to the task definition. So this is where the interesting part starts. So I will try to explain quickly what a task definition is. So if you have played around with other container tools, right? If you have played around, let's say with Kubernetes, you define a YAML file for your pods, for your services, and then you give Kubernetes those the essential configuration, and then it look at the configuration and bring up containers, right? It's a very declarative way of doing things. It's very similar in the Fargate. So what you do is you create a Fargate task definition, which tells AWS everything about your container runtime, what image you want to use, how much memory and CPU you want to utilize, and what other things you want to use. So it's like a full configuration, a huge JSON blob of what you want at runtime, and you give this to AWS, and you kind of declare it. So it's declarative in a sense that you create the full configuration, and then you give it to AWS rather than telling AWS what to do. It look at this configuration and figure out what to do, right? And if something goes bad, the configuration is still around, and AWS can kind of reconcile to fix the issue, right? So what we'll do is we'll create this task definition. It's very simple, but once we create it, we'll go and look at the actual JSON blob in AWS, and you will see that it's huge, and there are a lot of default parameters in here, right? So let's quickly see. Let's quickly while the security groups are being deployed, I will quickly show you how the UI here looks like. So once we create the task definition, it will start appearing here. And the task definition it is just a configuration, so it won't run anything. It will just save the definition. And then the next step is to bring up a container or like bring up a task using this task definition, right? So we will do that in the next step. So let me quickly save this and run this again to deploy the task definition. Keep throwing questions, guys. Cool. So it looks like the screen is fine now. Oh, it's cut on the side. So I think it's okay. As far as the content is visible, I think it's fine. Awesome. So let's deploy this. And let's have a look at how the task definition, the final task definition looks. And what we'll do is once the task definition is created, we will also create a task manually from console and then see how it runs. And then I will introduce another concept called a service, which is a high level concept on top of the task. So let's quickly go here, refresh this. It should appear. Yep. And let's see what is inside there in the task definition. So if you see here, it's a huge JSON blob, and this is essentially what we created using PullUMe. I just gave very few options, but most of the other things they assume either they are a null or they assume like a default value. But most of the things are configurable. So if you see, we have given it the container image, the image which we will run, which is here. This is our ECR repo image, and it kind of created like a whole bunch of configuration around it. There, one interesting thing is, if you see here, container is this is like one single container, but then you can actually create a list of containers within the same task definition. So you can give it a list rather than one single container. And the way this works is very similar to how it works in Kubernetes for your pods. And the concept is to run multiple containers which need to run very close to each other, which are related to each other, to run them on the same node. So if you give it multiple containers, it's guaranteed that all those containers are tied by a life cycle and they will be deployed on the same node. And uh, the concept is called sidecar. So you run a main container and then you run sidecars to it. And there are multiple use cases why you will do that. In this session, we will deploy only one container in the task. But one use case is to run a log aggregator next to your main container, like a Fluentd aggregator or something, right? There are other use cases like in Fargate, you can run a container which pull the X-ray, AWS X-ray configuration and forward it to AWS X-ray. So there are like multiple use cases for the sidecar container. Uh, but the crux of the concept is that you can bundle these multiple containers into tasks, and they are guaranteed to run on the same node close to each other. And make sure that when you deploy this, you don't want to do this for multiple services. If your services are independent, they should end up as different tasks rather than the sidecars. Your sidecars are smaller processes which are just kind of helper process for your main service. So only those kind of tasks should end up in the sidecar. Awesome. So this is created. If you see in the cluster now, let's do one thing. Let's create the task manually here using that, and we will deploy it in the public subnet. So I will go to task and I will say run new task, and let's select Fargate here. So if you see, these are the two options I was talking about: the EC2 type and the Fargate type. So the EC2 type is where you manage your nodes. The Fargate type is where AWS manage nodes for you. So I'm pointing it to the task definition, which we just created, the latest version of it, and then I'm saying this is my cluster. I want to run only one task, and let's select the VPC which we created. So this is the one, and let me pick the public subnet for now. So I'll put in the public subnet, and then we'll try to hit it and see if it is up. So let me select this, and just one. Let's just run in one subnet because we are only creating one task. And let us pick the security group which we created. So this is the one. This is the one which will let us let the inbound traffic on port 80. And let us see one thing. Yeah, so this is fine. So if you remember on my machine, I ran the container by default run on port 8083, but there is an environment variable which this container understand, which let it change the port when before it start. So I've given it here, so it will run on port 80. I just wanted to make sure it is there. So this is fine. Assign public IP, yes, and let's say run task. Yeah, so it is starting the task here, and once the task come up, you see it has a public IP. We'll try to hit this directly on port 80. So it should be fine once the container is up. Yeah, it is running, and let's hit this, and it gives back the response. So this is one single container running in the public subnet, right? And what we have done here is we started the task manually, and there is only one instance of it running. And the way these tasks work is you start the task and it runs as far as your container process run, and as soon as your container comes down, the task goes away, and it doesn't come up back again. So it ends when the container ends. And in this case, it is running because what our container is a long-running task. An HTTP API, right? So in this case, the task will not stop. But if I do stop it manually from here, you will see that the task goes away, right? And it will not come back. It will not start by itself. There is no intelligence here to kind of say, oh, the task got killed and it should like restart, right? So this is where the concept of service comes into picture. Uh, yeah. So what does the concept of service uh, do is it is a layer around the task. So let me quickly show you the image, the deployment image which we saw. So what we have done so far is we have created this goose task up here in the public subnet, and we have only created one instance of it, right? Now, what we want to do is ideally in with your workloads, what you want to do is you want to run multiple um, instances of the same task. You want to keep maybe run it in multiple AWS zones to keep it highly available, and you might want to scale it up and down based on the load, right? So you will run multiple instances of the same task at a given time, and the way you do it is by creating this concept of service, which is not an actual runtime. It is just again just a logical concept around just another abstraction around the task, and it tell AWS like how many instances you want to run. And once you do it, if you kill the task, AWS will make sure that the task starts again because there is a service attached to it, right? And you want to it will keep the required number of tasks up at any given point of time. And this is very handy because if you introduce a bug in your service or in your code and it dies um, while handling a request, the service will realize it soon and will bring up the container again. And you will not see this downtime if you have multiple instances of task running, right? So we will do that. But before this, I will quickly give you uh, some insight into what the task definition roles look like. So when we created this task definition here, you might have noticed that it created a task execution role, and it has also created a task role. So these are the two kind of roles which get created with AWS Fargate. And when you start with Fargate, this is like one of the confusing concept because it's not very clearly documented anywhere. So what task role is? It is a role which will be given to the container when it starts. So any permissions which the container need, for example, you might be talking to a database, or you might be accessing S3, or you might be like talking to DynamoDB or doing some other magic, right? So all those permissions need to go in the task role because task role is the one which will be assumed by the running container, right? The execution role is the one which is assumed by the underlying node. And this underlying node require permissions to pull the image before starting the container. And in some cases, it might require permission to push the log if you're using like some other solution other than CloudWatch. So that is what execution role is. So execution role goes to the node and task role goes to the container. So in our case, let's quickly have a look at what is inside the role. So I'll first open the execution role here. And if you see the permissions here would be around the ECR, right? So it's more open than it should be. So they should just restrict it access to our ECR. But for the sake of the demo, I didn't do that. So this is not how you will do it. If you are doing it in production, it will be much more confined. But this is what it is doing, right? So it has a couple of permissions here around the log streams to kind of push the logs, and permissions for pulling the image from the ECR, right? And if you look at the other role, which is the task role, in our case, it will have more again it has like more permissions than it should, but in our case ideally it should not have any permissions. So these are the default permissions which Pulumi gives by default because the library which I'm using like within Pulumi kind of try to bring up containers using lambdas, and they by default give these permissions, but ideally you won't give them. So in our case our container actually doesn't need any permission because it's not doing anything else with the AWS account here, right? So these are the two roles which get created. Awesome. So let's go back to our task and then the service concept. So what I did, I created a task. We saw it coming up, and then I killed it, and it never came back, right? Because um, it was just a simple task, not a service. So now let's create a service, and oh yeah. So I'll quickly explain what we are doing here. Let me take any questions if there are any. Okay, so fine. Yeah, so this is So this is the service. So what I'm saying here is there are a lot of things happening here, and ideally, when you create a service from console, you will have to handcraft a lot of things. Like you will have to connect it to the load balancer and do a whole bunch of magic around it. But because I'm doing it using PullUMe, all this is hidden in the abstraction in the library which I'm using here. And when you use something like some a tool like PullUMe, you have this freedom of building these high level abstractions um, like Lego blocks, which you kind of reuse across your infrastructure, right? So in this case, what this will do is, if you see it take security groups, and in the task definition, I passed the load balancer port mappings here, right? And what it does is it understands that I have created this load balancer and it is open on port 80. So what it will do is it will assign the same port on the, it will open the same port on the node when it run the container so that the load balancer can talk to it. And this is like one example of building a high level abstraction on Pulumi. If you do it directly through AWS CLI, you'll have to again mention the port and make sure that both of them match, right? But here you can kind of refer it from the load balancer which you have already created. So in this service, I'm saying use the same task definition which we created here. And I want two instances now. And because I'm saying assign public IP to false, it understands that it need to be deployed in the private subnet. So it will deploy it in the private subnet, and then the security groups will be attached to the running task. So let's do this. Let's deploy this. And what you will see is once this comes up, you will see a two task running under the concept of service, and both the tasks will be attached to the network load balancer which we created. And this is very handy because the load balancers in AWS understand the concept of service. And when you scale up this task, the new tasks come up which get the new IPs, and the service attach these tasks to the load balancer. You don't have to do it every time. So it's completely transparent to the user, right? So if you have heavy load and your task number increases from two to say 10, all of them will be load balanced by the load balancer immediately. And if you scale down, they get deregistered from the load balancer and it will go away. So let's quickly open the EC2 window while we see this. And let's find our load balancer. Yes, so this is the one. And if you see target groups here, so load balancer has a listener which is front facing, which tells like the port which is exposed is port 80, and whatever traffic comes on 80 is forwarded to this target group. And target group is the reverse facing part of load balancer, which kind of point to the services and forward the traffic to the service, right? So here we see it says, let's see targets. So you see there are already two targets which we started, right? Because our thing get deployed. So both the IPs are registered here to the load balancer. And let's go and have a look in the cluster. So in the cluster, you will see the service now. So this is the service, and it clearly shows that there are two desired tasks running, and there are like both of them are healthy. And within the service, if I go inside into the task, I have these two tasks running, and because they are in the private subnet, they won't get a public IP, so they are not reachable directly through internet. You can only reach them through the load balancer. So here, let's go back to service. So let's actually try to hit it and see if everything is fine. So in Pulumi, I have exported, I think, the load balancer URL, which is here. So we will hit this, and we will see if everything is up. Awesome. So this is working fine. And let me quickly show you something here. So let me hit this in our watch. So I can say watch curl this. Yes, so this is working. And let me quickly kill the task and see what happens. Right. Uh, let's go to the task. I'll go to the service tasks and let's kill this one, and everything is still fine. It is working. So this is hitting the API every 2 seconds. And let me kill this one also actually. So you will see it will stop responding because both the tasks are gone, and because it takes some time to realize that the task is gone and to bring it up again. So if you see uh, this, I think the other one came up. Yeah, came up pretty fast. So, but I think you got the point. We can try it once more actually. So if you just stop it, the service makes sure that the task comes up again. And this is like very handy to keep a highly available service running, right? Mm, is this actually hitting it? So this should not. Yep, it is not. So it's not responding. So I think that the watch was not looking at that. So because the tasks are down, and they will take some time to come back. And when the tasks come back, the service will again start responding. But ideally, you won't have like all the tasks dead at the same time. So you might have, even if one goes down, the other will handle the request, and then the other one will again come up to handle the load, right? So that's ideally what will happen. So this is uh, I think this is it what we wanted to cover. I think we covered most of it. So we created the cluster security groups, task def, we manually deployed the task, and we saw it came up, and then we deployed the ECS service, and we see how service make your task like highly available. Awesome. So any questions, guys, around this? So we still have 10 minutes. I can quickly talk about how you will use this in production. In what capacity have we used this in our project, in one of with for one of our clients, uh, and then maybe we'll say goodbye at 5. Just feel free to post the questions. I will take the questions now. Awesome. So yeah, so we in one of our engagements we deployed multiple services. On Fargate, it was a microservice architecture. We deployed more than 10 to 15 services, I would say. And there were lambdas involved. Some of the services, other services, more than 10 were kind of AWS lambdas. And we did all this using AWS CDK. So the services were deployed in a single cluster, and then we use App Mesh. AWS App Mesh is another offering, which is on the ECS front, which is a kind of service mesh between different microservices, and we use that, and the services were talking to other external services. So this was our use case, and I think it was fairly smooth, the deployment on AWS. We used code pipeline. Um, Everything was configured through code, and given a new service, like let's say you are a new project team, you want to deploy few services, you can using the code, you could potentially bring up all those services on Fargate within like a couple of days, the production ready services. And everything was managed through GitOps, through pull request, and the DevSecOps was kind of integrated into it, using Snake and other offerings. So so this is a fairly mature offering, and in the early days, Fargate was fairly expensive, but now because there is so much competition in the container space, they first reduced the pricing to half, like literally cut it down by 50%, and now it's fairly cheap. So in case you want to use it, just give it a try, and it might be a good fit for your project. Okay, so one question is still confused how the service is utilized. is it connected to the load balancer? So that's a good question. So I think I didn't explain it well also. So the concept of service here is just the configuration around task. It is not a runtime. So what it does is, so let's say you have to write this service from scratch, right? The the way you will write it is you will take the number of tasks that you want to run, and you will give it to the Fargate runtime and say, can you please run up these many tasks? And then you will monitor those tasks. And as the tasks come up, you will pick the IPs of the task and attach it to the load balancer. That's the only job of the service, to make sure that the number of tasks are running, and then they are exposed to through the load balancer, right? And the load balancer here is optional actually. So if you do not have any load balancer, the service will only take care of running the task, like keeping maintaining the number of instances of the task, and it won't care about like how many like are they exposed or not, right? Because these tasks might be of different nature. The task might be a batch job running which doesn't even expose an API, so it doesn't need a load balancer, right? So in that case, you will not do that. So service, the concept of service is just to hand over these IPs to the load balancer and to make sure that the number of tasks uh, are, uh, are maintaining the number which you gave. So that is what the service does. Yes, so the service is just configuration. So the target group, as you know, is created as part of the load balancer. So when you create the service, you give it a handle to the load balancer, and the service go and figure out the target group. You actually give it the handle to the target group, and then it just go and attaches its IPs to the target group. And one service can actually attach to multiple target groups. So you can have one service exposed, say, publicly to a public load balancer, and then internally to an internal load balancer. You can hand it multiple target groups. So it will just go and keep attaching IPs to the target group. That's what it does. And the service is just configuration. Yes, so the tasks are not in the target group. The task IPs are yeah, attached to the target group. So if you look at the target group here, these two IPs are exactly the IPs of the task here. So this is 182.2.0.9, and you see, if I refresh this, I think these are the old one. Yeah, so you see 182.2.0.9 here. So these are the IPs of the task actually. So the service is not a runtime. The task is the runtime here, and service is just an abstraction around it. And that's why if you see, the services doesn't get um, any AWS runtime attached to it. So the network interfaces are attached to the underlying node of the target, and that's why it gets an IP address. Awesome. Cool, guys. Thanks a lot. Please leave the feedback. You can do it on this page here. This is editable. You can go to the markdown here, edit it, leave the feedback, leave the comments, and the link for this page is in the description of the video. And please do that. And in case you have any suggestions for what topic to pick for the sessions, please leave that also. We'll try to accommodate that. It might be around PullUMe, and just giving a hint, it's an awesome tool. I would love to do a session around it, or it might be around any other AWS or other clouds which you are interested in. So we'll see if we can do that. So thanks a lot for joining. We will try to keep the cadence of episodes. We will try to do another one within a month, and we will keep you posted. Thank you. Thanks a lot.